All right, so in this problem, we want to find the values for B and C so that when you graph this, this graph will be continuous all across the real number line. So a good way to kind of, understand like what you're trying to do is let's just make a sketch of what we know about this graph. So in the XY plane, we got that when X is between 1 and 3, it's going to have this linear equation X plus 1. So then it's not defined for 1 and 3, but you can have just an open circle when X is 1 and an open circle when X is 3. So if you were to plug in 1 to here, you would get 2. So you would have like an open circle of 1, 2. And then if you were to plug in 3 into here, you would get 4. So you'd have like an open circle of 3, 4. Maybe something like this. And since it's linear, it's going to, look like this between there. Now, remember, this is the domain. So whenever the X values are outside of, 1 and 3, it's going to, follow this equation. And so to make it continuous, you essentially want the graph to connect to this dot from the left side, and you want the graph to connect to this dot from the right side. You don't really care what it looks like. You don't really care if it, bounces up and down, if it's straight line. As long as it's a continuous function and it connects to here and it connects to here. So essentially, you want to basically find values for B and C that will give you a Y value of 2, and values for B and C that will give you a Y value of 4. So let's go ahead. Let's first look at this side of the graph. So when you have f of 2, when you plug in 2, when you plug in 1, you want to get 2 for Y. We want f of 1 to be equal to 2, because then you're going to get that point. So then you set 2 equal to this equation. So you're going to have 2 equals x squared plus bx plus c. And again, when you're plugging 1 into here, that means that you're going to have 2 equals 1 plus b plus c, because the x value of 1 should make the equation equal to 2. Now, on the right side, you want it so that when you plug in 3 into the equation, you should get a y value of 4. So you want f of 3 to be equal to 4. So same idea, except we set the equation equal to 4. So we're going to have 4 equal to x squared plus bx plus c. And remember, the 4 is going to occur when you have x equal to 3. So we can substitute 3 in for x. So that would be 3 squared, or 9, plus 3b plus c. So now, see, you have these two equations that you can work. You have a system of equations that you can solve for B and C. 2 equations, 2 unknowns. So you can either, set one equation to B and plug it into the other one, or set one equation for C and plug it into the other one. I'm just going to go ahead and set this one equal to B. So let's take away 1, and let's take away C. And so we'll get that 1 minus C equals B. And let's clean this up a little bit. Let's basically just, well, actually, you don't even have to go any clean this up. Once we have an equation for B, we're just going to plug this equation for B into this equation. Wherever you see the B, you're going to put 1 minus C. And so you'll get 4 equals 9 plus 3 times 1 minus C plus C. Now we just solve this equation for C. So let's take away that 9. So we get negative 5 equals 3 minus 3C plus C. Take away the 3's, you get negative h equals negative 2c divided by negative 2. and you'll get C is equal to 4. Now, since you know C is 4, you can figure out B by just plugging this into here. And you'll get 1 minus 4 equals B, or B equals -3. So the values that will make this function continuous for B and C are going to be that B is -3 and that C is 4.